So hello guys, today we are going to solve a LeetCode question that goes by the name maximum length substring with two occurrences. Maximum length substring with two occurrences. The question number is 3090 and it appeared for weekly contest 390, that was today, and you can see the date and time. Basically it appeared for today's Sunday, and it appeared for 24th March 2024. Okay, you might be watching on some other day, but this appeared for today's weekly contest also. Okay, and many people were not able to solve it. I don't know why. Okay, if I tell you, like, you could be able to solve it. Okay, with the brute force also would work here. Okay, so I will be telling you about the brute force solution as well as the optimal one in this video. Okay, so let us first try to read the problem statement and then we'll go on to the solution. Okay, given a string is, return the maximum length of a substring that such that it contains at most two occurrences of each character. Okay, so what you are given, we'll first write what you are given. Basically we are given a substring s. We are given a string s. Okay, I am given a string s. What I have to do, I have to return the maximum length of a substring such that it contains at most two occurrences of each character. Okay, I have to return, I have to return maximum length of a substring, maximum length of a substring, maximum length of the substring such that all the characters are occurring maximum of two times. Okay, maximum of two times. That means I am talking about frequency. I am talking about frequency here, maximum of two times. So I have to get an idea of frequency. Okay, frequency means the number of times the particular character on an element basically is occurring. Okay, in an array or anything can be there. So two times, so it relates to frequency. So if it relates to frequency, what is the first data structure that is coming to our mind? Yes, unordered map. Basically map also we can use, but unordered map has a time complexity of 1 of fetching and storing. Okay, so that's why we use unordered map. Okay, if anyone didn't know why we use unordered map, this is the case. Okay, this is the reason. Okay, in map basically the map stores all the elements in a sorted way. So if you have to search for any element, you have to go through all the elements, all the sorted elements to get the element that you are searching for. Okay, it takes O of n time in the worst case, but this takes O of 1 time. So unordered map becomes a great choice. Okay, so now I know that I have to talk about frequency, and for frequency I have to use unordered map. Okay, because for frequency unordered map is the best solution to do. Okay, best data structure to use. Okay, what I have to return is maximum length of a substring such that all the characters are occurring maximum number of times. I'll take a test case and explain you. Okay, BC, BBC, BBBC, BA. Okay, so BC, BBB, CBA. BC, BBB, CBA. Okay, what I have to do is I'll declare a map. Because this map will be storing my frequencies. Okay, all right. What I'll do is I'll simply, like, I have to find a subset, right? I have to find a substring, right? What is my brute force solution that comes to my mind? I can basically generate all the substrings. And for each substring, I can check whether all the characters are occurring less than equal to two times. How can I do it? Basically, if I generate all the substring for this, I'll generate all the substrings starting at B. So B, BC, B, basically BC, BCB, BCBB, BCBBC, BCBBCBA, and similarly all the strings starting at C, all the strings starting at B, all the strings starting at this B, all the strings starting at this B, all the strings starting at C, this BA and this C. Okay, so if I'll consider all the substrings, okay, if I just start from this point, and I'll try to consider all the substrings, I'll make my two pointers here, I and J, I will be the outer loop and J would be following the inner loop. Okay, so for J, I'll store my B here. Okay, it has a frequency of 1. I'll move my J pointer, my J comes here. Okay, C is not already stored, I'll store it. Okay, are all the characters occurring less than equal to 2 times? Yes, so my maximum frequency would be updated, my maximum length would be updated. That would be updated by J minus I plus 1. Why J minus I plus 1? Because if basically my J is here and it has 0, 1, 2, 3, 4, 5, 6, 7. Okay, so 1 minus 0 plus 1 would give me the size of the array, Okay, I'll basically increment the J pointer. Okay, now I have stored C. I'll basically increment this. Okay, B would be containing 2. Okay, it is still less than equal to 2. So my MX would be updated. My MX would be now 3. Okay, MX would be now 3. Okay, see my MX is here. Okay, MX is here. Or I'll write it something below. Okay, somewhere below that you can easily see this. Okay, I'll erase this also for your convenience. Okay, now my J comes here. Okay, now what I'll say is my B becomes 3. B becomes 3. So if I check the frequencies now, the frequency of B would be greater than 2. So this is the point I will break. I'll break. Okay, I'll just empty my map. Okay, and I'll increment my I pointer. Okay, now my I pointer would be pointing here. And my J pointer would be starting from this place. Okay, I'll fill my map again. My C would contain 1. Okay, it is of size 1. My max is not updated because it is of size 1. I already have my max as 3. Okay, J points here. Okay, B is containing a frequency of 1. Okay, it is still valid. So my count is 2 as of now. Count of the elements, but my max is 3. Okay, I'll come to this. I'll just increase my frequency. My frequency becomes 2. Is it still valid? Yes, but it still contains 3. And 3 is already stored. Okay, I come to this point. Not this. Basically, at this point, I'll come to this point. And what I'll say is my B frequency is to 3. So when I'll check again, I'll see that it has a frequency of greater than 2. So this is the point I break. I'll come to this. I'll start from here. Okay, I'll empty it again. So it contains B one time. I'll increment my J pointer. Are all the frequencies less than 1? Less than 2? Yes. So my counter would be 1. Okay, J would come here. B would be incremented. B would be 2. Okay, B is 2. J would be incremented. My J is here. B is 3. Are all the frequencies less than equal to 2? No. My counter was 2. So it will be empty. My counter would reset to 0. And my J would be breaking out of the loop. Okay, my I would now point here. My J would be starting from here. Okay, I'll store B with a frequency of 1. Okay, I'll come here. I'll store B again with a frequency of 2. Okay, I'll come here. I'll store C with a frequency of 1. Okay, I'll increase C's frequency basically. I'll come to B. I'll increase my B's frequency, and now I'll see that B's frequency is greater than equal to 2. Okay, so this is the point I break. Okay, this is the point I break. Okay, I'll increase my I pointer. My I pointer is coming here. My J pointer is coming right here. Okay, my max is 3 as of now. Okay, 3 as of now. So I'll come here. I'll store my B as 1. My counter will become 0. Is it valid? Yes, it is valid. I'll come to here. I'll store my C in my map. Okay, C has a frequency of 1. All are valid. All are less than 2. I'll come to here. My B's frequency becomes 2. Is it less than? Are all the frequencies less than 2? Yes. My J comes here. Okay, A would be stored at 1. Okay, are all my frequency, and my C was 3 at this place. Now my C becomes 4. Is it a valid? Is it a valid array? Is it a valid map? Like all the frequencies are less than equal to 2? Yes, it is a valid. So as I can see, my C has become greater than max. So max would be updated. Max would be 4. Okay, so this was the dry run of the solution. Basically what I am doing is I'm considering all the subarrays and I'm making a map for all. Okay, And when I'm making a map for all, I'm again checking, okay, I'm again checking if all my frequencies are greater less than equal to 20, less than equal to 2. Okay, so if I just write the structure, it would be my outer loop, okay. Here my unordered map would be declared, so that it refreshes every time, okay. Basically char, we're gonna char, right? Yes, char int, okay, and mpp. I'll be giving I will be giving like this. I will be given with this j less than n, j plus plus, so that I consider all the subarrays, and for every element I'll just add it to my array, add it to my map, and then I'll again use a loop. That will check for all the map elements whether the frequencies are less than equal to 2, and if any of them has a frequency greater than 2, I'll simply break. Okay, I'll simply break. I can make a flag like it has broken down for this. Yes, it has been broken down. Okay, so it has been broken down. So not to add this, basically not to add this length. Okay, not to add this length. Okay, so this would be ending and this loop would be ending. Okay, and how will I store my maximum length? Basically, if the loop follows, like I can store my maximum length here, I can update my maximum length here, j minus I plus 1 comma mx. Okay, so bhaiya, you are using 3 loops, one this, one basically this, one basically this, okay. And you are saying that you said at the beginning that the brute force solution would work. What are the constraints that the brute force solution would work? Okay, let me show you the constraints. Okay, the constraints were from 2 to 100, and a computer can store maximum of, can perform a maximum of 10 raised to power 8 operations, So even if I use n cube, and the constraints are till 100, so it can be like 10 raised to power 3, so it will be like 10 raised to power 6, maximum at max. But if you will carefully observe, this map at any point of time can contain maximum 26 alphabets, because you know only 26 alphabets, right? So for this map can contain only 26 letters. So the time complexity for this loop would be O of 26, that is O of 1, and the upper two loops, this loop would be running from O of n, and this loop would be running for O of n. Okay, so it has a time complexity of O of n square, and that is getting solved in just like 10 raised to power 4 operations. Bro, you have till 10 raised to power 8. Why didn't you use it, bro? Okay, so this was the brute force solution. I'll attach the code. You try to write the code for yourself. If you didn't get it, just refer to my code. Okay, I'll attach the code in the description. Okay, no need to worry. Now I'll come to the optimal solution. What is the optimal solution? Okay, I'll consider the same example. I'll consider the same test case, BC BBB CBA. Okay, BC BBB CBA. Okay, this is my string. Okay, and I have to consider the maximum length substring such that all the elements are occurring less than equal to 2 times. Okay, so what I can do is, can I use a sliding window type approach? A variable size sliding window type approach? Because if I just put both of my pointers here, 2 pointers plus sliding window based approach basically. Okay, so if I just put my 2 pointers here, and if I just try to iterate through the array, till my frequency of the current element is less than equal to 2, I can simply update my answer. Because this will be valid. this will be a valid subarray, this will be a valid subarray till my frequencies become till my frequencies are less than equal to 2, it is still, it is valid, the subarray is valid. Okay, and whenever my any element frequency becomes greater than 2, so I'll increase my I pointer, till my that element frequency becomes less than equal to 2. This is what I have to do. I can simply iterate, I can simply use a sliding window technique. Okay, how? I'll just tell you. Okay, let me consider the same example, BC, BBB, CBA, right? Okay, I will be given a map, because I have to deal with frequencies. I will be using a map. Okay, I'll put my one pointer here, okay. What I'll do is I'll simply increase my j pointer, till my MPP of S of j, that is the j pointer's value, remains less than equal to 2, else I'll increase my I pointer, till it follows this condition, okay. And if there are any other elements that has their frequency equal to 0, so we don't need that elements, right? So I'll simply erase them from the map, along the way. We'll just see a dry run and then you will understand. Okay, j pointer is here. Okay, j pointer is here. I'll just see. Okay, and I'll take a mx that will be storing 0 initially. Okay, 0 initially, because I don't have any answer as of now. I'll come to j. I'll store it in my map. My b, basically it is still less than equal to 2. So it is valid. I'll simply increase my j pointer. I come to here. C. Is my C present? No. So it has a frequency of 0. Is it less than equal to 2? Yes. So can I increase its frequency? Yes. Okay. And can I update my maximum? Yes. I'll update my maximum to 2, because j minus I plus 1. Okay. I'll still update my j value. Okay. Okay. B. Is B present? Yes. Has B a frequency? Like I'll increase it. Has B a frequency less than equal to 2? Yes. Okay. So I'll update my max. To 3. Okay. I'll go forward. My j comes here. My frequency becomes 3. Okay. So is it less than equal to 2? No. This is where my case fails. Okay. Like it is less than equal to 2? No. Okay. So what I'll do is I'll simply increase my I pointer till this frequency becomes less than equal to 2. So, and I have to decrement the frequency that I am like moving upon. Basically, till I have till here this index, I have till here this value, I'll simply be decreasing it to this range. Okay. So now my map should only contain these elements frequencies. So this frequency would be minimized, like this frequency would be decreased. Okay, so I am increasing my I pointer. I am basically decreasing its frequency. I'll decrease the frequency to 2, and I will be moving forward. So my C would be here. Okay, you're getting it right. Basically, this was my window. But now my frequency had become greater than 2. So I'll have to decrease it. I'll have to increase my I pointer. So my B would be excluded. I would be incremented. Okay. Now is my conditions following? Yes. And when I increase it, I'll simply increase my J's frequency. for the next element to be monitored. Okay. Because it has been already monitored. If I don't increase my J, then it would be again counted. That is not to be done. Okay, I'll come to this element. Is the frequency? I'll increase its frequency. Is the frequency less than equal to 2? No. So what I'll do is I'll simply increment my J pointer. Okay. but before incrementing, I'll reduce its frequency. So it becomes 0. If it becomes 0, I'll simply delete it from the map. Okay. I'll come here. My I would come here. Okay. Is my frequency less than equal to 2? No. I'll still decrease the frequency of B. My B's frequency becomes 2. I pointer comes here. Okay. And when my I pointer comes here, when the condition has been fulfilled, I'll increment my J pointer. Okay. I'll come to this point. I'll store this frequency. Is it following the conditions? That less than equal to 2? Yes. Okay. I'll still update my J. My J would come here. I'll update my B's frequency. My B becomes 3. Is it following the conditions? No. So when it doesn't follow my condition, I'll simply decrease its frequency, like decrease the frequency of the character that is present at the ith position. So B frequency would be decremented, and I'll move a step forward. Is it following the condition now? Yes. So I would come here at A, and A would be stored as 1. Okay. A would be stored as 1. Is it following the condition? Yes. Okay. So my max was 3, but still, now if you can see, the size is 4. Okay. So my size would be incremented to 4. So is 4 my answer? Yes. And this is the string that you get as your answer. So we are using the 2 pointer plus sliding window based approach. Basically, what is our scenario? That till my elements becomes less than equal to 2. That element that is being added has a frequency of less than equal to 2. I'll simply update my maximum and I'll increment my J. Else I'll update my I value. Till my MPP of the current element, like the current element that is to be added, has a frequency of greater than 2. Till I'll increment. Okay. Till then I'll increment my I pointer, and before increment I'll just decrease its frequency. Okay. If the frequency becomes 0, I'll simply decrement it. Like I'll simply erase from the map. Okay. I'll simply erase from the map. Okay. And I++, and after my I has been incremented, I'll increment my J pointer. Okay. I'll try for the second test case. A. Okay. And my map is like here. My I pointer would be here. My J pointer would be here. Okay. So my A would be pointing at 1. Yes. A has a frequency of 1. Okay. I'll increment my J pointer. My A has a frequency of 2. Okay. That is still okay. My max has a length of 2 because 2 is the maximum length that we are considering. Okay. I'll come at A. A's frequency would increase. Okay. Is it less than equal to 2? No. Okay. I'll increment my I pointer. And on the way I'll just decrement my frequency. Okay. And when I do this, I'll simply increment my J. Okay. And I'll increase my frequency. Is it still less than 2? No. So I'll increment my I pointer. Okay. I'll decrement it. Okay. So now, is it less than 2? So is it less than 2? Yes. So I'll increment my J. And my J has come to the last position, and this is when I stop. If I try to write the code for this, basically what you need is, another map that I just told you. It will be of character and int. Okay. What I need is I and J pointer. Okay. I need a length that we have to travel to. Okay. Until when I have to travel? Till my J is less than n and my I is less than n. Okay. And I'll just store the frequency at every point. If my MPP of S of J stays less than equal to 2, and I need a maximum size, that will be considered, that will be initially 0. Okay. It will be storing J minus L plus 1 comma mx. Okay. And J plus plus. Else while MPP of S of J greater than 2 and I less than equal to J, what I'll do is I'll simply decrement my ith frequency, basically just incrementing my ith frequency and ith value and decreasing the frequency at the ith position, frequency of the element at the ith position. S of I equal to 0, I'll simply erase it. Okay, and what I'll do is I'll simply increment my I pointer and I'll simply increment my j pointer. Okay, and what I'll do is I'll simply return mx at last. Mx at last. Okay, let us try to run it. Okay, it has ran successfully. Okay, I'll try to submit. It has been submitted successfully. Okay, so what I'm seeing is basically we are using a sliding window, variable size sliding window technique. Okay, I am just increasing the frequency at every point, and after increasing the frequency, I'm just considering if the frequency is less than equal to 2, if it is still less than equal to 2, I'll update my max, if it is not less than 2, not less than 2, I'll try to decrement, I'll try to make the frequencies less than equal to 2, and in the step there can be frequencies that can be equal to 0, so delete them, and in the process I will be incrementing my I pointer, and after I have incremented my I pointer, that is, and when my frequencies are in control, I'll increment my j pointer. Why? Because so that it is not counted again. Okay, so if I talk about the time complexity and the space complexity, my time complexity is basically O of n, because we are traversing just once, basically 2 into O of n. Okay, why? Because like for the 2 pointers, maybe like they're traversing for 2 into n times. What is my space complexity? Am I using an extra space? Yes, for the map. Okay, so O of n, or like basically 26 characters would be there, so it can be O of 1, because at max 26 characters, so it would be O of 1. So this was the overall solution to the question, maximum length substring with 2 occurrences. I hope you guys like the solution. If you have any doubts regarding the solution, just ping it down in the comments, and if you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.